This Week in Radio Tech, episode 262, is brought to you by Axia Audio and the Axia Radius networked IP audio console. Throw your budget a curve and meet Radius. By the Telos Zip 1, the world's most advanced IP audio codec. And by Lavo and the Crystal Clear virtual radio console. Crystal Clear is the console with a multi-touch touchscreen interface. More radio engineers are installing IP radios as studio transmitter links, or STLs, even in, and perhaps especially in, rural areas like Altus, Oklahoma, where the terrain is flat and unlicensed Wi-Fi bands are relatively uncluttered. Braden Pickett joins Chris Tobin and Kirk Harnack talking about IP radio equipment selection and configuration. Hey, welcome into This Week in Radio Tech. I'm Kirk Harnack, delighted to be with you from a different place than my usual office. I'm at the studios of WKXY, Kicks 92.1 in Cleveland, Mississippi. Been part of the station for quite some time in various incarnations, and glad to be using their studios today. I've got a couple interesting things to tell you about what we're doing here at Kicks that tie in today's show. This is episode 262, and as usual with us, it's hot, humid, sticky, yucky. I had some ticks on me earlier from working out at a transmitter site, but tick-free on a cooler day in New York City, it's Chris Tobin. Hey, Chris, welcome in.
Thanks, Kirk. Yes, I can honestly say I'm tick-free. And it is a cooler day and overcast here in New York City this evening, but other than that, it's really good. Having a good time.
All right, you are, I guess the location's undisclosed, but if we got really snoopy, we could figure out exactly where you are from the buildings and the skyline around you.
This is true. It's in Manhattan. It's on a balcony. It's several feet up. And, and there's a dog running around the balcony to keep an eye on things. So I have security, I have a view, and I have my Goose Island IPA. So I'm doing just fine.
All right. Well, I'm awfully glad you could join us. And Chris, the topic of this show once again is we're going to be mixing packets along with audio and RF. And to me, that's just such a fascinating subject. You know, for I guess from the early days of electronics, back when back with the phonograph, and Bell and his telephones, and then we at some point along the way we got RF either from Marconi or Nathan B. Stubblefield in Murray, Kentucky has some claim to fame there. I'm not sure what that is, but we had RF, and then we had audio, and then RF, and then somewhere along the way we got some computer technology, and in the computer technology we gained this technology that has to do with packets, and it's a very interesting way. When you think about what packets do, every packet, has a from address and a to address and a little bit of metadata about what's in the packet and then the data that's in the packet. And with this standard chunk of information, we can do an awful lot, just an amazing amount. And that's been quite a revolution over the last 10 or 15 years for broadcasters, as well as for businesses and every other kind of technology. So let's bring in our guest. Our guest is Braden Pickett. And Braden is a fellow who I met on Facebook. I don't think, Braden, you and I have met anywhere else but on Facebook. And Facebook's another one of these technologies that uses packets to bring together people who have interest in audio and RF and all kinds of other things. Braden, welcome in. Glad you're here.
Hello. I'm glad to be here tonight.
We're glad you're here, and thanks for agreeing to be on the show so quickly and readily. One of my favorite things to do is to talk to engineers who haven't been doing this a long time, who have who likely have no closed ideas about the way things ought to work, because you're still in the process of discovery. I'm sure you probably recognize there's plenty of things you don't know, and you're still learning about them, and so you have an open mind about how things could work and what you might do to make them work better. Tell you what, I got to do a quick commercial here to help pay for our show. And then, Braden, we're going to come back, and Chris and I and our audience would love to hear a little bit about, kind of how you got into the world of computers, and then how that led you into broadcasting. You're watching This Week in Radio Tech. I'm Kirk Harnack, along with Chris Tobin in New York City, and Braden Pickett, who is in Altus, Oklahoma. And so Our show is brought to you in part by the folks at Axia and the Axia Radius console. Now, this is an audio over IP console. In fact, that console, the one you see pictured there on your screen, that Radius console is the same kind of console that our show is coming to you over at the GFQ studios in New York. GFQ is using a Radius console for a couple of reasons. One is that it was very easy to wire into their facility. I got to go up there and meet Andrew Zarian and help him wire it in. Really, he and I both together wired it in. And operationally, it's so cool because, a podcast network like Andrew's GFQ network makes a lot of use of Mix Minus. Every single Skype that they bring in, every remote guest, remote host, this very show right here has 3 simultaneous Skype inputs going on that console. And for every Skype input, for every input of any kind that needs a backfeed, an audio backfeed, this console creates one for you. You don't have to fiddle with knobs. You don't have to make sure you've got the right buses pressed in or not. It just knows what to do. And now, as the engineer who sets the console up, you do get to set some rules, but you don't have to get down deep in the weeds. It's pretty easy to set up. You just tell it what kind of a source is coming in. And, that's just to tell the console, hey, this is likely to be a mono source, like a telephone hybrid. Or this is an IP codec, which could be a stereo source, and you may want to have a split feed going back to the person at the other end. Or this source is a microphone right here in the same studio. So their back feed is basically going to be a headphone feed, but you can interrupt it with a talkback button. So there's just all kinds of things the console just knows how to do based upon what kind of input that you tell it that you have. And that's one of the real magical things about a console that's defined in software. The other cool thing about the Radius console and why it's very popular among so many stations is that it's really inexpensive. It's a very value priced. The Radius console itself consists of 2 parts. There's the surface that goes on your desk that you touch. You have the faders that you move, and it's got the meters and all that. And then there's the engine part, the DSP engine. And the DSP engine is really multiple parts. It's got some audio inputs, mics, line inputs, AES in and out, line level out. Of course, it's got Ethernet, but not only does it have Ethernet, it has an Ethernet switch built into it. So you don't have to go buy a separate Cisco or HP switch. You can use the switch that's built right into it. And the switch that's built into it, some of the ports offer power over Ethernet. So you can even power your Telos telephones with those very same ports. One cable, and you got power and data and audio all going to a Telos telephone as part of a Telos phone system. You've got some ports on there that are SFP. So if you have an SFP module for fiber or some other kind of connectivity, you can plug it right in there and use that. Plus, it does have some gigabit ports and some 100 megabit ports. So if a small console that's AOIP that is affordably priced is interesting to you, I really wish you'd go check it out on the Axia website. AxiaAudio.com will get you there. It'll actually take you to the Telos Alliance website. From there, click on Axia and click on the consoles. And you'll see the Radius 8-fader AOIP mixing console. We have these at my radio stations in American Samoa as well. Here at this station, we've got the larger, the Element console. Actually, this is a 6-fader console. It's actually one of the smallest Element consoles you could have. And it's pretty old, too. This console is, it's almost 10 years old. And it's been just plugging along just great. All right, thanks to Axia at AxiaAudio.com for sponsoring this portion of This Week in Radio Tech. All right, back with Braden Pickett. Braden, why don't you just kind of give us a little fill-in on how you got interested in IT, and then how in the world did that lead you into an interest in radio?
Well, I started out just like every other person my age. I was working with Windows XP and basically just figured my way around everything in it. And soon after that, I was probably 5th or 6th grade at the time, and I built my first Active Directory. My house of 5 computers, so it was pretty nice to be able to control everything. And things like deploying software. It was awesome to have Microsoft Office deploy by itself, and VNC, and and setting policies to get everything lined up and even.
Mm-hmm.
So I started out with that, and I pretty much cruised along with that. And my IT department at the school, they were pretty friendly with me. and they would give me surplus equipment and stuff that they didn't need anymore. And I had several switches at the time, and I would just use them to do every mundane thing, bridge them all together and then use one port on them to go to one thing. So I didn't use them as a 48 port switch. I would just have them basically dedicated to do one thing. And after that, I pretty much moved sort of into radio. I started out as a board op at my hometown station here in Altus, KWHW. And soon after that, I got more into the engineering department of it, helping a friend of mine who's also the engineer here.
Mm-hmm.
And it's just kind of gone up from there. And so we were faced with STL that had failed. And so we needed another cheap alternative way to do it. And the station didn't have, at the time, the money or mean to pay for it to get it repaired and relicensed to a new digital STL or anything like that. So I convinced them to buy a set of IP radios from Ubiquiti and encoders, and we ran audio 16 or 17 miles over this IP link to our transmitter site.
So you said you used some encoders like MP3 or AC kind of audio?
They are Horizon Horizon Worldcast units.
Yeah, yeah. Those they may be using the APC algorithm.
Yeah, and we ran them non-compressed, and they've been working flawlessly. So that's basically that's kind of where everything came from. So
now, what gave you the idea to even try something that? Well, look, if you want to do an IP audio link, traditionally, this is not in the catalog of most broadcast equipment dealers. You won't find Mosley now makes some IP links, so that's great. Their Rincon system, it's very bulletproof. It's an awesome system. But other than that, you won't find Ubiquiti stuff in broadcast dealer stuff. What made you think to put this together over maybe what you might call consumerish IP link?
Well, obviously I knew you could encode audio over IP, and one of the things that the other engineer was concerned about was the delay. Mm-hmm. And basically we found that if you ran them uncompressed, most of the delay that was in the link was because of compression. And so we ran them non-linear, and there's maybe a quarter of a second delay in it. And you can use it on a remote. You just pull an earbud out, but mostly in the studios they use program because they don't want to hear themselves in their own ear.
Yeah.
And so and I think most engineers are just scared of audio over IP because of delay. So
that's interesting. Hey, Chris Tobin, you can jump in here. When I got into radio, and I'm sure when Chris got in too, everything was analog. Nothing was digital in the chain, and digital does usually introduce some delays. Every disc jockey, everybody just listened off the air. The signal would go through the console, through the audio processor, which was analog, through an STL system, through the transmitter, which is all analog, over the air, which is all analog, the tuner that was all analog, back into the headphones, and there was no appreciable delay. Almost none. And so everybody always listened off the air. I see. It's the when you said node, it's the node at the studio. Okay, well, we gotta fix that, don't we? With no delay, that's what everybody got used to. Then we started introducing digital audio processing and digital exciters and digital studio transmitter links, and all those things added some delay. And after you add them all together, individually they're not so bad, but when you add them all together, then it started to become unusable in the ear. And then with so many stations going HD radio, well, obviously that's 8 or 9 seconds of delay, and you can't use that at all in your ear. You have to listen to program material with that. So, point was, Chris, take us, I guess, to the point. Modern engineers, people coming into the business now, like Braden, they're accustomed to not listening live off the air. that seems almost like a foreign idea, right, Chris?
Well, yeah, I mean, if you've been in the business long enough, you remember those days of listening off air directly, and that was a novelty, and that's what you did. But as you pointed out, things have moved forward. Time marches on, technology evolves, and nowadays, you know what? If you don't listen off the air directly, that's not the end of the world because you're still. It's all about the conversation you're creating, the storytelling you're doing on the radio. So if you can't hear yourself off the radio, that's okay. It's not going to be the end of the world. But with the new stuff today, and Braden is experiencing it, is being exposed to it. I think it's the best time. It's great.
Yeah, and it doesn't matter now if before you had an IP audio link, if you had some digital things in there, you might have a grand total of 10, 12 milliseconds of delay, and you could just about stand that. That wasn't so bad. But now when you got coded audio and packetization and all this, you're going to end up with some much longer delays. In fact, at this very station right here, actually it's a sister station. We just located a second transmitter at our transmitter site in Mound Bayou, Mississippi. And this is the one where you've seen some videos of me on Facebook talking about putting in the Ubiquity link. Well, for LiveWire and for almost any technology to work over an IP radio link, there's a lot of jitter in the IP radio link. And so you have to, at least in LiveWire, use a standard stream that uses larger packets. It has more delay, and at the receiving end, there is a bit of a buffer built into it. You can set the buffer within some range, but there is some buffer. So you end up end to end with, even though it's not compressed, you still end up with probably on the order of 35 to 40 milliseconds of delay. Most of that due to the buffering at the receive end, because it's going to sit there and wait, make sure all the packets come in. So yeah, you can't. You could use that for a remote, and as you said, Braden, you start your remote and you pull your plug out because you're hearing it, 30 or 40 milliseconds delayed. So you can use it for queuing, even if it's half a second. You can still use that for queuing like they do in television. Boy, come think that television has been dealing with this kind of delay for a long time. And you've seen it when the anchor will say, okay, now we go to Bob, down the road in the next town where the damage was. It'll take, Bob down the road, what seems like quite a while on the air to start talking. Anyway, yeah, so we deal with delay, and that's a normal part of life, and I don't see that going away anytime soon. So Braden, you also were telling me about your growing interest in RF. Are you into servicing audio and transmitters now as well, Braden?
Not so much with high voltage RF. I mean, I've worked in a Continental transmitter with someone else who grew up with the Continental transmitter. But no, I mean, not as much RF as I am networking and audio. So
sure. Hey, so at K101 there, was that KWHW in Altus?
No, that's KWOX in Woodward.
Oh, KWOX. Okay. Well, which station was it you were telling me that you have some studios that were designed by Jack Selmeyer?
That was KWOX in Woodward. Yeah.
Okay, yeah. Well, Jack Selmeyer is a legend, in broadcast engineering circles. I just actually got to talk to Jack about a month ago. He had some questions about some gear made by Telos, and so I was answering those for Jack. But then there's another name that popped up in our conversation. It was Jim Turbeville. Turbo had built some studios, and you came in after him. Is that right?
That's right. I mean, this was back in 1983. December 16th, 1983 is when they signed on. And Selmeyer built it, and Jim Turbeville finished it for him. So, and they've been through several engineers since. Unfortunately, I don't know what it is, but some of them have died of cancer. And yeah, I hope that doesn't happen to me. But it's
So what I'm wondering is this: you've got some experience under your belt now. You mentioned Ubiquity IP radios and an APT WorldCast codec. So in your experience, and you also mentioned that you've put up some other links for other radio stations. What equipment are you finding are you comfortable with? You mentioned Ubiquity, and I think you also mentioned that you're part of a business, a wireless ISP that uses a lot of Ubiquity gear. I guess just talk about some of your experiences with this gear and why it's working out well for you.
I use Ubiquiti, and I started out with Cisco AeroNets, and as I was saying earlier, the school district used to use Cisco AeroNet 1400 series to distribute their internet connection from the Board of Education to all the different buildings. And so when they discontinued that, they gave most of it all to me. And so I had several links from downtown building all the way
I
back
take it
across
we've
to the
lost
radio
audio from
station,
everybody.
and back to my house, and um, they were 1990s
Take a
technology,
look-see at this.
and they were just too slow, basically. And so I wanted to upgrade, and I went to Ubiquiti. And the main thing that I noticed with them is they're affordable. I mean, you can get a 5
Pull the
gigahertz
node
nano
out of the rack.
station,
Just
which is
unscrew it
basically
and
their
pull it out
flagship
halfway.
IP link,
Give it
for
some air to circulate
$60,
around it.
$70. The only problems that I've ever had with Ubiquiti products are lightning. I have had 2 rockets blow up, which are their carrier class backhauls, and once I started using their shielded cable from Ubiquiti, it's called Tough Cable. Never have had a single problem with it.
Any idea what it is about the tough cable that has reduced problems?
If you look at the Tough Cable, it has the carrier class at least. I haven't actually used just the regular Tough Cable Pro. Tough Cable Carrier. It has the anti-crosstalk divider, and then it has an aluminum foil shield, and the metal jacket, the braid, and then it also has a carrier. Let's see, what do they call it? The rip, not the ripcord. The ESD drain wire is what they officially call it.
Ah, yeah.
And
Okay.
they also make connectors that crimps to, so it just bonds your radio to the ground. And ever since I put those on the radios, I've never had a single problem. And lately, we've actually been having a bunch of severe thunderstorms here, and just straight over the mountain that we're on, and never had a single problem with it again.
Talk to me a little bit about the link that I put up here. It's only 6 miles, and I'm using this little Ubiquiti NanoBridge M5. It's a 5 gigahertz link. Talk to me about link budgeting. How do you figure out which model or how big of an antenna that you're going to use? And how do you figure out if your path is clear and how high up your towers you need to go to get a good clear path? I know engineers know how to do this. They typically do it for 950 megahertz links, but maybe 5.8 gigahertz is a little bit different. Talk to me about planning.
Well, 5.8 gigahertz is very you need line of sight for 5 gigahertz. 2.4 would bust through something. Excuse me. 2.4 would bust through buildings a lot easier, and trees and all that kind of obstacles much better than 5 gigahertz will. And so yes, there is a lot of lining up and figuring out exactly where the sweet spot is. And Ubiquiti's come up with a very good way to do it. And they have a utility that you run on their radio that has a beeper built in. And the higher the frequency, the better the signal and the frequency that it beeps at. So that's mainly how I would align them. They've got air. I think it's air. It's not Air View. It's I'll think of it. I'll think of it in a minute. It's it uses Google Earth data.
Yeah.
And you put your location of one radio in, you put your location of another radio in, and it tells you how high you need to be, and shows you what speed, what theoretically you would get out of it. So.
Hey, I just found this. I used this site myself to plan this link. It's airlink.ubnt. Yeah, airlink.ubnt.com. And you're right. You have to have the Google Earth plugin for your browser, but once you got that, it makes it really easy to plan the path.
Yeah. And in terms of what products you want to select, the highest product that I've ever used is the Rocket, and I've used both the Rocket and the Rocket M Titanium. The Titanium has a GPS feature in it, so you don't get the let me see what else they call it, It's crosstalk between other 5 gigahertz radios on the tower. They call it, let's see. Oh, where is it at? No, that's not even the right page. No co-location interference. And
okay.
with that GPS, it will actually sync the bursts on all the radios. I mean, if you have 2 Rocket Titaniums on a tower, it will sync them to where they both transmit at the same time and aren't picking up different bits of data.
Oh, so they're not hearing each other on the same tower,
Correct.
interfering with each other. Okay, that's interesting.
Correct.
I didn't know that.
And another feature on those, they have a gigabit interface, and all the standard rockets do just have 10100 interface.
Okay.
And let's see, I get all my names with these mixed up because they all start with like air and then blank. And
yeah, air this and air that. Yeah. Marketing.
It's basically with distance. I mean, it's distance and throughput. So with a rocket dish, I mean, you could easily go 30, 40, 50 miles and without a problem with 5 gigahertz. And I mean, you'd be pretty flaky with a nano bridge with what you could get on throughput with that. And recently they came out with a nano beam. I'm not too impressed with that. I've bought 2 of them, and the way you mount those is just not appropriate to me.
Okay.
Now, go ahead.
Oh, well, it seems like one thing that's attractive about most of the Ubiquiti stuff is it's inexpensive. And so, Chris, you can probably chat about this because I know you've dealt with some pretty expensive radios as well. I guess as an engineer, I don't want to buy a $15,000 radio pair and make a mistake, have it not work well, or find out the hard way that I didn't plan something right. But if I buy a $300 radio pair and hook it up, and by golly, it works. Now I've got some confidence in setting this kind of stuff up. It really is like a new discipline in engineering, at least for me. Tobin, what do you think?
Well, it's a new discipline for a lot of folks who aren't familiar with RF. If you're an RF person, basically link budgets, Fresnel zones, antenna gain, and all those things are just common practice. And there are tools, both Ubiquiti offers them, so does the other manufacturers of some of the higher priced 5.8 gig links. And if you use the tools and understand all the different parameters, you should be able to create or build a link that's functional, whether it's the lower end price or a higher end price, like say Redline brand, and where they have carrier class technologies and all kinds of stuff. But both systems use the same technology. It's just how they design it. And Ubiquiti stuff is really robust. I mean, it's an IP67 standard outdoor enclosure design, so you could get away with a lot. And the nice thing with the Rocket, the entire transceiver is in the palm of your hand with an end connector on the top of it, so you can get yourself any size antenna you want for the link you're trying to create. So you got a lot of choices. You can go high end or low end and still get the same results. The trick is just the link, understanding what you got, how the heights and locations.
Chris, it's something I still can't wrap my brain around because I began with so much traditional broadcast technology, is if you look at a traditional broadcast STL transmitter, a 950 megahertz STL, and that's not quite microwave frequency. It's it's close to a gigahertz if you count that as the beginning of microwave. But a 6 watt, 8 watt, 12 watt STL transmitter, it's a heavy device. It's got a big power supply and a strip amplifier in there, and it just seems like it's expensive and typically well made. I'm not saying that they're chintzy in any way. They're very well made, and they put out a bunch of power. And you hook this power to typically a half-inch coax or bigger, and then you go up your tower to a Scala or a Mark antenna, and it just seems like a lot there to get this signal out. And then you buy Ubiquiti or some other brand. The ones that I have are these little dish. It's not but a little over a foot in diameter, and the entire radio is in the feed horn, the whole Ethernet interface and the RF parts, and even the antenna is just 2 little pieces of wire that come out of the circuit board. They're cut to the right length, they're set in the right place, and my brain says, how can this work so well when I spent years and many, many, many thousands of dollars on 1 gigahertz links that were analog or perhaps digital? Chris, has this ever bothered you? I'm still wrapping my brain around it.
No, it doesn't bother me because I'm an RF nut. So it's like for me, it's just higher the frequency, the smaller the components. The technology
Yeah.
has shifted such that those traditional, we'll say the PCL 505, 606s, the Mosley links that are 950 megahertz could easily be built in a package probably half the size of what they are now. You have to also remember back in the day when you and I were starting out as mere techies, engineers, whatever you like to call it, the technology it was state of the art. Those Mosley boxes, the TFT boxes we all familiar with, and the Martis, that was state of the art, and that stuff was as miniaturized as it could get it then. As time has gone on, miniaturization of RF components has been astronomical. I mean, fractal antenna design is what they use in cellular phones. Those little whiskers of wire you're using for your 5 gigahertz link, it's based on fractal math, and that's how they make these antennas now. So what we are accustomed to, the large antennas, some of them can be shrunk down to small little PC board type stuff. Matter of fact, most of the cars today, if you know that little shark fin on the rooftop or maybe the trunk of your car, that's a fractal antenna. That's how they get all the multiple frequencies that we received in there, from satellite radio to AM and FM.
Wow.
It's pretty cool.
Wow. Gee. Hey, you're watching This Week in Radio Tech or listening. Glad you are here listening or watching. It's the show that we do every week where we talk about broadcast technology. And on this show, Chris Tobin and I are talking with Braden Pickett. Braden is an 18-year-old young man, is very interested in engineering, and he's got a lot of good IT experience under his belt, and he's been getting into radio for a time now, and especially excited about IP-STLs. So that's what we're talking to Braden about. Our show's brought to you in part by my friends at Telos and the Telos Zip 1 IP audio codec. This thing is just freaking amazing. We were talking about a lot of stuff in a small box. The Zip 1 actually has several different personalities, several different things that it can do. One of them would be you could use it as a studio to transmitter link. And you can, because the beauty of IP technology, you can use any link that that has reasonable performance, whether it's the public internet. One of our guests, Dave Anderson, is doing that to a bunch of his actually all of his transmitter sites using public internet to get high quality audio, program audio to the transmitter sites. You can use IP radios, as we've been talking about on this show. You can use a combination. At some places, you may not be able to get wired public internet close to your transmitter site, so you bring it as close as you can. And you put up a pair of IP radios and you shoot it the last 4 miles from, wherever the nearest place is that you have public internet. That's another way to do it. You could use satellite internet. There are people doing that. Now, the Zip 1 is also appropriate for doing something a little more pedestrian, like remote broadcasts. And the reason why the Zip 1 is good at remote broadcasts is because it's easy to use. For the remote broadcast technicians, personnel, the talent that goes out to a remote broadcast, they don't have to know IP addresses. They don't have to, know an IP address and a port number to dial home, to dial the studio. In fact, there's a video on the Telos YouTube channel that shows a young man, and he doesn't even know how to dial a Zip 1. He plugs it in, and it dials the last location to which it was connected, which is always the studio. And when he's done, he doesn't even unhook it. He just pulls the power on it. Amazing. And it works every single time that he's gone out and set up a remote for Lightning 100. Look for the Soul Shine Pizza Lightning 100 video on the Telos YouTube channel, the Telos Alliance YouTube channel. It's amazing. It works well over 4G wireless systems like Verizon, T-Mobile, Clearwire. Works great over those types of systems. It does do Wi-Fi. You can plug a Wi-Fi stick into it. I believe it comes with a Wi-Fi stick. And so you can hook it up that way. We do recommend using a wired connection whenever you can. The other thing about the Zip 1 is it will it has a number of different codecs in it. So if you need a really low bit rate and yet as good a quality as you can get, it has AAC enhanced low delay built into it. That's one of the really cool codecs. So it's 64 kilobits per second you get fantastic 20 kilohertz stereo audio. If you want to do a more high quality codec, you can use AAC at up to 320 kilobits per second. If you want to use aptX, we were talking about the aptX codec earlier. That's an optional codec in the Zip 1. You can even do linear audio too. You can just send linear audio formatted nicely. It'll go across the public internet or across your private link. So check it out on the web if you would. The Telos Zip 1 IP audio codec. Really easy to use from the front panel, and it's got a great web interface now. The latest software gets rid of Java. It's now JavaScript, and it's so cool. I'm very proud of this product that Telos has been developing for some years. It just keeps getting better and better. Check it out at telosalliance.com. Look for the Zip 1. All right, so Chris Tobin and I are talking with Braden Pickett. Braden, actually, I meant to ask you before we took the break. If an engineer like me was going to plan another link between studio and transmitter site, and let's just imagine I'll give you a real world situation. From the very studio I'm at now, I would like to end up going 23 miles to a tower site that has no chance of getting public internet. It's way out in the sticks. What are some things that I need to think about regarding dish size and gain, or where do I need to start in considering getting? Well, let's even talk about LiveWire. Getting a really solid link out 23 miles away.
Okay. Let me preface that. Do you have the ability to get a license for 950 megahertz?
Yeah, we could do that.
Okay. Ubiquiti makes their AirMax Yagi antenna, and they make it 900 megahertz. You can mount that to a pole with a let me see, make sure that we can get, yep. Okay. And then upon that, I would recommend that you get a Rocket M with the Rocket M. They make the titanium. Do they make a titanium M9? Okay, they don't make a titanium M900. However, if just like I said earlier with the shielded cable, it's probably unlikely if it's way out in the sticks that there won't be any other 900 megahertz radios on the tower, correct?
Right. Now, so what's the benefit of the 900 megahertz band for us?
You said it was 27 miles?
Or 23 miles, yeah. Now, we do have, I did a path study, we do have line of sight and Fresnel zone clearance. So there's...
Okay, well,
go ahead.
In that case, well, if you do have the clearance and you can get high enough, probably. What's the weather situations there? Are we looking at constant ice or?
Well, here it's in the south, so we get ice about every 3 or 4 or 5 years. So that's probably not a big concern. We get some fog. We get a few frog strangler downpours from time to time. If it was on a 5 gig link, I could imagine that there would be some rain fade from time to time, but maybe not. I don't know.
Okay. In that case, probably just a rocket dish with a 5 gigahertz rocket on it. If you're not going to have much of a problem with ice, you can always get radomes. Ubiquiti does make a radome. I don't think they call it a radome. I can't remember exactly what I might sound like it, but I don't work for them.
It's all right.
Probably just a rocket dish with the 30 dBi gain. I wouldn't worry about having to go to the 34. The two that I have, linking 8 miles, I believe, are just the 30s, and I don't see a need for the 34 dBi gain. Again, that is over 8 miles, but I mean I've saturated the signal on it, so probably a 30 dBi rocket dish with a 5 gigahertz rocket with rocket titanium, and go ahead and put a titanium on the tower, so you can have the GPS functionality of it.
Okay. All right. So what other things do I need to think about? These dishes, do they add very much loading to a tower, or are they fairly diminutive?
They're they're pretty lightweight. Can tell you an exact weight. I mean, they're probably under 3 or 4 pounds. They're not very heavy. Um, I've got four of them, just stacked on top of each other, basically on top of some RON 25. So,
Hmm.
no, they're not very heavy at all.
Chris, now you've got some experience, I guess, with some more expensive products than Ubiquity. What would you advise me if I said I've got a 23-mile path in rural Mississippi? Where should I start thinking about?
Well, first thing you do is run the program that Ubiquity has. Ubiquity has that is on their site for point A to point B.
Hmm.
Go with the largest gain antenna you can get your hands on. Try to go with I think the Titan series is a MIMO, so you have multiple in, multiple out antennas. So you want both polarizations so you can spread the broadband. And the Titan also, I think, is a TDMA protocol, so you can get yourself some carrier class bandwidth. What do you call it? Throughput. But I would go with their link budget program and put the numbers in and go with the largest dishes you can find that your tower will support. Typically, a 2-foot dish is a nice way to start on both ends. That'll give you a good gain. At 5.8 gigs, at 23, 27 miles, yeah, you want to get a link budget that's really robust.
Okay.
Yeah,
So
start with
I
that.
want to. I guess I need to have plenty of margin, as we would call
Yeah,
it.
you need a lot of fade margin.
Fade margin.
I
Yeah.
did a shot. I did a 5.8 across the Hudson River from Midtown Manhattan to 10 miles into New Jersey, and the transmit site, the height was about 400 feet, 420 feet above ground. That was our studio location. It was a rooftop of a office building, but the
Yeah.
receive end at the transmitter site was only 25 feet above the ground because it was a directional AM, so we couldn't put anything up on the tower at the time. 5.8
Oh.
gig isocouplers didn't exist. So it worked though. But what I did was I used 2 foot dishes at 5.8 and did the full power. And our link budget was about 25 dB. And no matter what the weather conditions were over the period of 9 years, we never lost the link once. Nor did we ever get into the danger zone of the RSSI. And we ran, what did we run? I think it was 100 megabits across that. It was a 12-mile run. But it was overkill. But it was reliable, it was needed, and it worked. That was 12 years ago. Stuff has improved considerably since then.
Hey,
And it was only a
mhm,
single polarized antenna. It wasn't MIMO.
Ah.
So
Okay. Hey, so Braden, I've got a question. When I first got these Ubiquity radios, I really didn't know, and I guess I really still don't know. I set them up to be transparent, to just transparently bridge my network out to the transmitter site. So I didn't know. Okay, each of the radios has an IP address, so you
Right.
can access it. And I made them IP addresses that are on that same network. I don't know that they had to be, but I gave them, that network's IP numbers that would work. And I wanted the gear at the transmitter site to just look like it was on the same network. Is that the normal default, or what are a couple of my options for if I wanted if I wanted the foreign network to be on separate IP addresses? Could I do that too?
Well, it would depend. It depend on the situation. I mean, if you have a WISP, and you need every client to have their own network, I mean, and you don't want to have clients with backfeeding DHCP into your network, obviously.
Right.
And is what I had always set them up to do. Any client would be in Soho router mode,
Mm-hmm.
and that would isolate them from the rest of the network and also act as a DHCP server on the LAN side. So they could plug their router in and it wouldn't mess with it. That, or they could just get a Pico station or another access point down in their house.
Okay. Okay.
In terms of carrying everything, no, you don't have to be on the same sub. Your IP of the radio doesn't have to be on the same subnet if it's in WDS Transparent Bridge.
Okay. Okay. Yeah, I noticed that's the mode I put in. They call the WDS Transparent Bridge. Now, we've mentioned a couple times here that I'm extending LiveWire out to a transmitter site, and to me that's kind of like the ultimate in performance. If you can get live wire clocking and everything to work great at the transmitter site, you've got a pretty transparent and probably robust IP link. If, for example, I couldn't get that to work, hope would not be lost. It would just mean that if I wanted to stream linear or coded audio to the other end, I guess the dirty little secret is the clocks of the two devices. If I've got a codec at my studio and a codec at the transmitter site decoding that, their clocks aren't necessarily the same. And once in a great while, you're going to have some sample slipping, and you may have some kind of a glitch in audio here and there. Whether you could hear it or not it depends on the manufacturer and how well they cover such things. But with LiveWire or any other AOIP, studio type system, your unit at the transmitter site is going to want to be slaved to the clock at the studio, the ones the transmitter slaved to the studio, so that they have exactly the same clock. So you never get any sample slipping ever, because they're essentially running on the same clock. So I guess my point in all that is, if you're, and Braden, you correct me if I'm wrong, and Chris, you might want to chime in too. If my understanding was, if I'm want to run the Ubiquity radios pretty much in their default mode, they got all kinds of error correction turned on, and they've got this time slot stuff turned on to make it seem more TDMA. Those two things don't help LiveWire or other live clocking schemes. But if you're going to do voice over IP for telephones and email and web access and things like that, then those technologies are great. They can make the link seem like it's working better. But if you want to run something like LiveWire, or perhaps AES67 or anything with a distributed clock, then you may have to do what Dave Anderson has told me and what I found out for myself, and that is, you got to turn off all the fancy schmancy automatic stuff that the good folks at Ubiquity have figured out to do. You got to turn all that off and just run a very naked and fast system that doesn't mess with your data. Braden, have you found that to be true?
Last week, I just got back today, but last week I was up in Woodward, and another engineer who's been working at the tower had told me that every once in a while he's been hearing the station drop out. And I went back. I use what's called Zabbix. It's an open source SNMP monitoring software, and it would every 5 minutes I had it set to ping the radio itself and find out what the connection speed, transmit and receive is. It would show the air max and the air max quality and air max capacity, and signal strength. And the signal strength would say all the way. I mean, it wasn't being moved, so the signal strength would stay up, and there wasn't any rain fade or anything like that.
Right.
And he just kept saying that it would drop out for 5-10 seconds at a time and be fine. And what I found was the APT Horizon boxes are two-way encoders, so they encode left and right and then decode left and right and send it both ways.
Yeah.
So there wasn't any audio being encoded at the transmitter. We were just using it as a one-way STL at the time.
Right.
And he just said it was dropping out for 10 seconds. And when he looked back on the APT logs, it would show that the APTs actually lost connection to each other.
Okay.
And so then I did some further looking into Zabbix, and I would see that the AirMax capacity would just jump to 0. Couldn't figure out why. And my horizontal and my vertical signal strength was absolutely fine, no problem. And I just turned off AirMax to give it a shot, and it's been running 260 megabits absolutely fine, no problem.
Gotcha. Yeah, and I remember that the AirMax, it's some great technology, but it's not necessarily appropriate for persistent, consistent, never a break. There's never a break at all in the packets streaming from one place to another. Chris, you've dealt with some different radios. What have you found, generally speaking, about their settings to make live audio work?
Same thing. Turn off a lot of the features that I'll just call error correction. You got to remember, they're working in a world of bursty data, very short bursts of streams of data back and forth, and that dropping out for a few seconds, if it was cyclical, most likely was probably the boxes resetting, the AirMax app or the AirMax protocol is probably resetting itself or resyncing. and that's why you get the interruption of the audio. I had a couple of products do that years ago with a couple of links I was playing with. I'm like, why is this happening? And it turned out that the software was designed to it counts, clock cycles for something within the box. They won't tell you what, and it would just reset, split-second reset. But in continuous or persistent audio, that's a dropout. So that's probably what happened. If you turned off the AirMax protocol or AirMax feature, odds are that's what it was doing, was resyncing itself.
Gotcha. Yeah, yeah. And I'd always, at working for Telos, we'd always been told by our customers who had made these IP radios work was that, yeah, you got to turn off all the error correction, anything fancy in there. And I was reading up on the Ubiquity radios that I had about the AirMax feature, and oh my goodness, they've put a lot of effort into this. This is a really cool technology to just help everybody in a multiple user environment work well, work consistently, and it handles a lot of functions automatically. But it's really no good for LiveWire and maybe for other persistent, consistent streams. It's great for bursty data and optimizes everybody's usage there, but not as an STL, not as a replacement for a piece of wire between two places. And then I confirmed that with Dave Anderson, who was on our show a few weeks ago. He said the same thing.
Yeah. So your 23-mile link, you're going to need to really make the RF section robust.
Yeah.
Since you're going to be turning off a lot of ahead that you'd be using to correct any issues.
Yeah. Okay.
Got to give that some thought.
Well, and one of the interesting things about these radios is they've gotten so cheap that you can afford to have a backup. Just buy a whole second system. The expensive part of any of these radios is the labor in putting them up and tying down cable and getting surge suppressors and doing all the actual work of putting them up in a robust way that a broadcaster is going to want to do.
Yeah. Oh yeah. Well, the nice thing is because you can mount the transceiver behind the antenna, you reduce the issues with losses in the cable and the RF between the antenna and the transmitter. So that's a good thing. And then what you do is you make up for that with the shielded twisted pair static drain cable. I forget what the Ubiquity calls theirs, but basically you do what the phone company used to do with their wires they would string from pole to pole. And you shield it, you ground it properly, and then you're off to the races. But yeah, you go with the large antennas though.
This brings up a good question, and Chris, you may know the answer. Braden, you may know. So usually, now as you mentioned, it's Ethernet from some port on a switch up to the radio. Actually, you're probably going to go through a PoE injector and then go up to the radio. The PoE injector, though, is passive except for adding that power. Point is, with Ethernet, you do have a limit on the copper of 100 meters, 328 feet, and all the timing protocols built in are have that in mind. You might go a few extra feet, but what if I've got to put my Ubiquity or other IP radio, let's say 550 feet up the tower, significantly more than 328 feet? Now, Dave Anderson addressed this. He said, well, we run fiber and then we inject power, convert it back to Ethernet and inject power up the towers. Then you've got a run of 110 volts up there, I suppose, or you maybe got a run of 24 or 48 volts going up there. Braden, what do you do if you got more than 328 feet to the radio?
Well, if Mr. Sellmeyer was here, he could tell me exactly what I would do.
He's a good man. He would know.
The Omnicom Tower, which is where K101 and all the sister stations and TV and several lease people who lease space on there, it's a 1,204-foot tower, and there are platforms at 960, 670, and 760 and 650 foot on the platform. So I put my rocket dish probably 10, 15 feet below the bottom platform, which is more than high enough on that tower. And I ran their Ubiquity's tough cable up the tower to a enclosure where previous tenant used to actually have a, I don't know exactly what the system's called. It was a farming, some kind of farming GPS location thing. I'm not absolutely positive what it is. But they abandoned all their equipment in place and terminated their contract. and they just so happened to have fiber from the 650-foot platform all the way down into the transmitter shack.
Oh,
So
okay.
so I put a Cisco switch, an 8-port Cisco switch. I don't remember the exact model with an SFP module in it, and ran fiber straight down the tower. So my copper run was only 30 feet long.
Gotcha. Okay. Chris, how about you? What advice would you give people who've got to go over 328 feet to their
You do a fiber conversion. It's
Yeah?
just like they do for distributed antenna systems for cellular in buildings where they can't run the RF several thousand feet. They do fiber. It's what they've done.
Oh,
They do it at Penn Station, Union Station, Washington. The cellular services are distributed through fiber. Fiber nodes are brought out to places where they break it out to RF, and it's like Brendan said, it's 30 feet of coax, and the rest of it is all fiber back to the control center or network ops or a network frame.
now would that imply that you've got to have commercial power up at the level where you're converting to copper?
There's different ways to do it. I forget. I haven't looked into it recently because I haven't had to go over 328 feet with any of the Ethernet projects I've done. But I do know from working with an engineering firm, there are methods of doing power. I'm not sure if it's the fiber cable itself has a power jacket in it.
Oh,
There's a
yeah.
couple of
Okay.
there's a couple of ways to skin the cat, so to speak. I haven't looked into it. I'd have to do some research to get you a better answer. But I know there are solutions. There definitely are solutions, and it's not uncommon.
Well, one of the things that I like, talking about these different options and concerns is that, hey, if you're an engineer out there considering doing an IP link, but there's something holding you back from doing it. Well, we can't do it because we got to be 600 feet up the tower and there's no power up there. Well, guess what? Just talking about here, we all know that there are solutions to it. We may not have the exact answer, but the point is there are solutions to make that work. And the benefits, oh my goodness, the benefits of getting our network that's here at this studio out to our transmitter site in Mound Bayou, Mississippi, are terrific. I can browse to our Nautel transmitter, and I couldn't do that before. So it's exciting to get in networking out to a transmitter site that's just out in the middle of a bean field. It really is.
Yeah, absolutely. Braden, when you did your tower location, you said you had 30 feet of cable. Is that at the top end with the ubiquity devices?
Yes, yeah, and on the inside it just goes straight into another Cisco 2960 switch that everything in the rack is connected to.
Right. So let me see if I envisioned this correctly. You have fiber down the tower to a SFP or SFP connection downstairs in the transmitter room for your switch. At the other end of the fiber, you have the same thing. You have a switch up there. Was there power provided in that utility box?
Yes, the tower, as I said, it was 1,200 foot, and when it was built to have leased repeater cabinets in it. So yes, there's plenty of power. There's 3 phases of power going up the tower.
Oh,
And,
so they built the platforms with repeater capabilities. Gotcha.
Yeah,
Okay,
yeah,
that
yeah.
makes sense.
That's
Okay.
that's the moneymaker of the tower. So
Yes, no, it typically is. But yeah, the larger towers, that's what they would do, distribute the power. Okay, utilities brought up there. That makes sense.
That's good. All right. Hey, guys, we're about out of time. I'm going to tell you about the console from Lavo called the Crystal Clear in just a second. Both of you, if you would, be thinking about a final word for us, whether it's a tip, something that you're working on that's really cool, maybe a question you'd like to ask our audience to see what they say back. But anyway, just some kind of a final thought. Be thinking of that while I tell our listeners and viewers about Lavo, Lawo. They're a German console maker, and they make some beautiful, big audio consoles, but they also make smaller consoles for radio broadcasters. And now they make the Crystal Clear console. It's part of their Crystal series, but the Crystal Clear is very interesting because the surface itself that you touch is a multi-touch touchscreen monitor. Now, you've been hearing me talk about this. If you're a fan of this show, you hear me talk about this console for about a year now. If you haven't checked out the video that Michael Dosh did, it's on their website at lawo.com. Now, I'm going to stop talking about this until you go check it, okay? So go check it. Look at the video that Michael does from the NAB show, actually last year, 2014, where he takes you through a tour of how this console works. It's really pretty cool. Now, there's like every console, it's got to have some hard hardware inputs and outputs, and it does. There's a one rack unit box that provides some microphone inputs and some analog and AES inputs, analog and AES outputs, dual power supplies if you want that. It has an Ethernet connection for a Ravenna / AES 67 AOIP network. It's got some GPIO on it to run your tally lights, give you contact closures for other things like to start your turntable. If you're still doing that, you can do that. And then the part that you use that the disc jockey actually touches is a multi-touch touchscreen monitor. You could mount this in a piece of furniture, like on the desk. You can tilt it up. You could have it almost straight up flat if you want. Anything you could do with a touchscreen monitor, you can put it right next to your automation system if you want to. Might be a bit of a reach. You might want it closer. All kinds of ways that you could do this, limited only by your own imagination and what you think is appropriate for your particular broadcast operation. So the Surface itself, the clear part of the crystal clear is this multi-touch. It's a PC with this really nice touchscreen. It's running Windows 8, and the app is an app that just takes over the whole screen. You can't even tell if there's Windows 8 running behind there. The app takes over the whole screen and looks like a beautiful Lavo console. Really well designed, terrific German engineering, and it's the coolest thing is that every button that you might push is contextual. So if you want to adjust something in the mic section, you touch the options button for the mic, you get options for that mic. You don't have to swim through a bunch of menus, and you don't have to look at a bunch of stuff that doesn't even apply to what you're doing. Now, like many software-defined consoles, the Lavo Crystal Clear does automatic mix minus. It does talkback to people who are on headphones or people who are remote. It does all the normal stuff that you'd figure it does. Built-in time of day clock that's NTP synchronized. Beautiful PPM stereo meters. Linear faders right on the console for your monitor volume and your headphone volume. You want to check this out. It's very cool. It is AOIP. And it's made by the folks at Lavo. The website is Lavo, that's LAWO.com, LAWO.com, and look for radio products and look for the Crystal Clear console. And what I really want you to do is check on that video. There's a link to it right there. You see in the upper right corner. It's Michael Dosh giving you a tour of how that console works. Thanks to Lavo for sponsoring This Week in Radio Tech. All right, let's hit up Braden. Braden Pickett's been our guest today, young man, and really learning the ropes. And Braden, what thought might you like to leave our viewers and listeners with today?
Well, if you need cheap and affordable, well, I shouldn't say that exactly. Cheap, affordable, and solutions that work to send IP audio over long distance, go to Ubiquiti. I mean, you can always find something that even if it's not the right product for you can always find something you at least want. And the possibilities with Ubiquiti are pretty much endless. I mean, if you can make a hop, then go for it, and just see what you can do. You need something to experiment with, and if it doesn't work, it's $300,
or less. Some of their products are even less than that. And you bring up a good point. I always wanted to learn about routers. I always had an interest in, okay, what does a router do, and how can I make it do something cool for me? So, in my junk box, I probably have 10 routers, and they're all cheap. Until I went around and finally got a good MikroTik router, and I love that thing, and it hasn't failed, and it's still inexpensive. But that's a good point. Buy some gear, try it out. Make a test from your house to your neighbor's house or down the street or from, wherever it's convenient to get two dishes or antennas to point at each other and just play with it.
Yeah. And you speak of routers. I've got a Ubiquiti Edge router, and I've run it for a year and a half now, and no problem. It makes all kinds of nice little graphs. I don't think I can share the screen with you, but this is like the main interface for it. It shows really nice interfaces of my inbound and outbound bandwidth. It's got all the interfaces here as well as VLANs, and it's really good. It's a really easy way to get control of your network. So that's my little Ubiquiti spiel for the night. Probably for the month.
I've learned a lot, actually. I'm glad you said this. I mean, even though it sounds like a commercial for Ubiquity, maybe we should get them to sponsor the show.
Oh, maybe.
Is if you go to their website, they have a lot of learning, tools and information to learn about. And I love that the tool we mentioned earlier. What was the website for that?
Airlink.
Airlink.ubnt. Yeah,
Yes.
airlink.ubnt.com, where you can look at your path. And just by the way, it'll work for any path. I mean, if you want to look at a 950 megahertz path, you can use the same website. It's geography. So
Yeah. And another thing I would probably add on to that, I didn't talk about it much tonight, but Zabbix. It is a open source monitoring service that uses
yeah.
SNMP, and I know we're kind of short on time, but if you're interested in that and you need something that can make really nice graphs for you, if you have like online UPSs, most of them support SNMP protocol, and you can get a notification to your cell phone whenever power's lost somewhere, whenever a voltage is low, temperature's high. I mean, there's all kinds of sensors that you can add to Zabbix, and it's all open source. So I mean, if you know how to experiment with it, go ahead and experiment with it, because I mean, this is a future of technology, and it's ease of use basically.
How do you spell that?
Zabbix.
I see. I wouldn't have gotten that right. Zabbix.
Yep.
Zabbix.com, org, do you know?
Let's see. It's .com. Yes.
Okay. All right. Cool. All right. Good tips. I got that written down. I'll check it out later tonight. Chris Tobin, have you got a tip for us before we have to leave?
I'm going to go with 2 tips. One, if you're doing a 5.8 link, definitely look at the antenna side of things and give that some thought. There are many options. Radio Waves is one of the manufacturers of pretty decent parabolics at 5.8. They're designed for outdoor use, and they work really well. And the other tip is a friend of mine who does voice work was asking me about using his iPhone with an application that he could record stuff, track audio, and then FTP it back to a studio. So I found this Pocket Record Pad, which I thought was pretty cool. And I just realized it's handy for folks that are doing news and sports. So if you're a station that has the FTP capabilities locally, and you have reporters and sportscasters and whatnot need to get audio back, this might be something to consider, because the microphone on the iPhone is quite good. So if you're not using a plug-in mic cable, the mic itself is not bad. And I just used this week to record an ad hoc group of kids going through a tour of a studio, and they were singing with the studio producer. And I FTP'd it back to the guy. He's like, I can't believe it. It worked perfect. So just, oops, the screensaver. But I just thought I'd throw that out there for those folks that may be looking for something that, or maybe someone may have requested, hey, I need to record stuff on my iPhone. I can't carry a recorder. I'm going somewhere that's just going to be sort of low key. It works really well. So I just thought it'd be something to throw out there.
Pocket Record Pad, and I love the FTP part. It seems like a few months ago I was tasked with finding some Android software that does the same thing, and I found some. And you know what? Hey, if something costs $2 or $10, if it works, it's worth it. So don't be afraid to spend a few bucks on an app if it does what you want. But yeah, you can even format the name of the file, so you FTP it right up to your station's FTP server, and then from there, it could be grabbed automatically by your automation system, plugged in on the air. So you can easily do a remote broadcast with something like that.
Oh, that's exactly how this was put to use. Yeah, it was exactly the same thing. Yep.
Good deal. Good deal. Hey, gentlemen, thanks so much. Braden Pickett from Altus, Oklahoma, thank you for joining us, especially on short notice, and sharing your experiences with us. It's really been enjoyable to have you on.
Thank you, Kirk. I always look forward to seeing videos on the TELUS Alliance YouTube page, and I was hoping to make it to NAB show this year, but I was actually still in school, so I couldn't get out for that.
Another good show to go to is the Texas Association of Broadcasters. They have a really good show there. Big.
Yeah. You know Patrick Roberts, correct?
Yes.
Okay. He's invited me to go to the OAB convention that they do at the Cox Center, and I thought about going to that, and I just couldn't get away from Altus long enough to do it. So yeah, I'll try to do something with broadcast conferences this coming year. So.
Well, I hope to see you in person sometime soon, and if not, we'll see you again on this show and on Facebook. Thanks for your postings there. Chris Tobin, you're available at support@ipcodex.com if people want to tap into your expertise.
Absolutely.
All right. Good deal. Thank you so much for joining us from beautiful Manhattan, New York City, where the sun is going down. It's getting a little darker, and it's going to be a good night to probably eat out somewhere in Manhattan.
Oh yes, there's a nice Lebanese restaurant up the block that's got great food. So I'm toying with the idea of doing that with some nice wine, and it'll be good. It'll be a very good evening.
I'm probably going to McDonald's, but I'm in Cleveland. I'm in Cleveland, Mississippi. Actually, we're you know what? We're going to go to Catfish Cabin and get a steak. So I will have something like something. Nice. All right, thanks so much for joining us, folks. Thanks to our sponsors, Lavo and the Crystal Clear console, also Telos and the Telos Zip 1 IP codec, and from the folks at Axia and the Axia Radius console, the console that is producing this very show right now. And thanks again to also to Suncast and to Andrew Zarian, who are producers of the show. I think Suncast was producing the show tonight. We'll see you next week on This Week in Radio Tech. Bye-bye, everybody.